guys? So we're getting on the lecture for this week for today. We're looking at still chapter 9 and getting to 21 as well. We're looking at number one, of course, the block construction. Understand that we have different blocks set up that we have. We have short blocks. Of course, those only have the pistons and the crankshaft and the timing chain installed already for you there. Long block, of course, has all that, plus the cylinder heads installed and torqued. Especially we see that a lot on engines. That when we've gotten engines before in the classroom, we've done long block motors before. So they come up, and then of course we also have another thing called crate motor that has everything on it. It's got the block, the cylinder heads, the intake manifold, the oil pan, and the timing chain installed correctly, and along with the timing chain cover. And that's pretty much a whole unit there. Intake manifold, cylinder heads, valve cover, everything, it's all torqued. So it's basically, we're gonna dump it in there and transfer all the parts into it. Very limited amount of adjustments are required because it's a crate motor. It's already been checked out and torqued and balanced. So of course those are more expensive, by the way, when you buy those there. But typically the block has a lot of machining surfaces. Of course the cylinder walls are one. The lifter valley area where the lifters rest up inside and mount on a camshaft, especially on an OHV type of engine. We have those lined up there for us. Of course, we're made out of cast, and then we've got some aluminum as well. Then we've got some of the engines that are integral with stock, especially on cast engines, where they do not have sleeves. It's all integrated. But once that integration wears and it requires any type of boring, then we need to look at probably do a couple of things. One of them for sure is putting a dry sleeve in it. And with dry sleeves on page 186, that's pretty much installed and it's pressed on into the engine bores all the way through to compensate for a worn out cylinder. We will get a chance to do a demo on measuring the cylinder for out of roundness, and then there's another taper adjustment to be done that I will do in the lab area in my garage. So the dry sleeves are pretty much for cast irons. The wet sleeves that can also be installed on page 186, they're basically for aluminum engines. Those are coolant passages that come up with, and it's held in together tightly with the cylinder head when it gets installed. On page 186 kind of gives you the difference between both of them, where you have water jackets and coolant flowing on an aluminum engine, which would require more of a wet sleeve than a dry sleeve. The other thing we look at, of course, is cylinder block deck surface. We'll do a demo on the straight edge on it, just like we did in module 3, where we got a chance to do that while we were still in school. And we got a chance to measure the 5 points on the cylinder head, and I told you later on we're going to be doing that 5 points on a block deck surface, and I'll get a chance to get that demoed out for you guys. The camshaft, like I said, the main bores on that are in the block. They're precisely machined with cam bearings in it on an OHV type engine. You have cam bearings that get installed in it. On the main bearings, of course, you have main bearing bores that are machined precisely where the crankshaft rides and fits into there with main bearings. The different types of caps that we can see on a particular crankshaft as it's rested in place with main caps are typically a 2-bolt stock main, and then we've got some 4-bolt mains, which are a little bit more durable for much higher horsepower engines. And then we've got 6 bolts, and we got cross bolts, which we have conventional caps screwed into the bottom, and then you got cap screws that go to the sides. Some vehicles have that. And then we got a girdle plate that's one big main bearing cap plate, and typically you'll see that on page 190. This one Volvo, shows that a Volvo belonged to this guy here, but I've seen them on 94 Toyota Camry where they have a bed plate on it. So we did one not too long ago, about a semester and a half ago, at the school, where we worked on a Toyota Corolla, and it had a bed plate too, and it was a 2009, 2009, that we did a long block on. So we got a chance to see that. The crankshaft construction, again, we've got a chance to look at crankshafts. We talked about them a little bit more. You've got your main journals, you've got your rod journals that we have to look at, and we've got a chance to mic those main journals and do the rod journals as well to check for wear, out of roundness and taper. We got a chance to do that in the previous worksheet. Of course, the oil passages have to be very clean on page 190 in the bottom of figure 918. We see that there. You also have the weights, the counterweights, we call them the throws. Those have to counterbalance the engine during the power stroke. So that's what those are there for. We kind of mentioned that earlier. But kind of keep in mind that if there's any wear and tear on it, and we're going to get into this in the bearing section of it after a while here, we'll talk about the different types of and sizes of bearings that we see fit for particular engines with crankshaft issues, where you have journal wear, and we'll get into talking about that a little bit later on, not too far later on. Keep in mind on the main bearings, on the crank bearings, they're split half bearings with a tang on the end, just like on connecting rod bearings. There's one machine bearing called a thrust bearing that's a little bit different from the others. It's got a tang on the sides and it protrudes out on the sides of the cap. What that bearing is designed to do is to prevent excessive fore and aft movement. The crankshaft's got to have a little bit of in play. Otherwise, if it didn't, it would run rough and we would have premature engine failure. So it's got to have a little bit of in play. Typically, 2 to 3 thousandths, depending on what the manufacturer specifications give on that. It could be about up to 5 thousandths I've seen. So, but that's where you have to consult your specifications on it, just see and check for in play. And I'll do a demo on how to do that with a dial micrometer coming up. Keep in mind that that thrust main surface there is designed to help that fore and aft movement. On the crankshaft, you also have a crankshaft snout area that locates the sprocket or the pulley or the harmonic balancer onto place with the Woodruff key, what we call a Woodruff key, that locks in place. Make sure if you send the crank out and you get the crankshaft back, make sure that Woodruff key is installed on there. Sometimes I have gotten cranks back from the machine shop and they forgot to put the Woodruff key in it. So make sure it's there. If not, you need to call the machine shop place and let them know, hey, where's my Woodruff key? They're very easy to take off and very easy to install. So crankshaft oil seals, of course, it helps. That's in the front of the snout. The rear back of the snout. It mounts up to the timing chain cover area, and that pretty much is under high pressure. The oil pressure is stemming up, anywhere, but we've seen them about 40 to 60 pounds of pressure, 70 pounds of pressure, 80 pounds of pressure with wide open throttle. For every 1,000 RPM is going to go up a 10 psi increase. But that oil seal is designed to help prevent oil from leaking out of the engine through the timing chain cover. So if it's compromised, it will leak severely. And so that oil seal is designed as pretty much a one-piece neoprene seal. We see that in the front, and then we also see that in the rear main seal. So we've got a seal in the front, and then we have one in the rear that we look at. And typically some rear main seals are a one-piece unit. Pretty much today, there used to be where there were a two-piece unit, which were easy to take out without having to remove the crankshaft. But nowadays, they make them as a one-piece. So the only way you can replace it is to remove the transmission to get it done. The connecting rods, we know that they mount up, and we talked about that already and showed you the demos on that, how those kind of go into play and how they fit perfectly around the journals there. And if you got any issues with that, then of course we're gonna have a problem. But we got a chance to look at that and talked about the bearings on those things. That the pistons on there are select fit per each cylinder, so that's why it's so important that I mentioned to go ahead and make sure that when we remove the piston from that cylinder, we want to put it back in that same cylinder. So we want to mark them. We want to mark those and make sure everything's okay with that. And it goes right back into where it was before it came out. Coming forward here, moving on forward to we're on page 205 there in the book. Bearing characteristics, of course, the bearing's made out of Babbitt material, copper or aluminum, depends on what type of design you have. But typically bearings got the bearing characteristics, which are load strength, conformability, embeddability, corrosion resistance, bearing crush, and spread. The one that we need to deal with quite a bit is bearing crush. And the reason I talk about that more right now is because when you put the bearing, whether it's on a rod bearing cap or a main bearing cap, the bearing surface compared to the side of the cap is slightly protruding, and it's designed to be that way. So that way when you put the caps together, the bearings touch each other, and as you torque it evenly in a 2 or 3 step process, it crushes the bearing so it has a better conformability and embeddability when you have them installed. That's why when you go to install bearings, we lubricate the bearing not on the back side of the surface as it fits the cap, but on the front side of the bearing where it's going to meet with the journal, whether it's the connecting rod bearings or the main bearings. We never ever we want to put the back side of that bearing dry when we install it, and then lubricate the bearing in the front as it meets up in contact with either the main journal or the rod journal. In this case, we're talking crank, so it's going to be the main journal. That's what that bearing crush is designed to do for us there. The different types of bearings that we see on those, the standard, undersized, and oversized bearings on page 206 in your book. Standard bearings will come factory. They normally will have an STD and a number on it on the back side of the bearing. If you have to, or if the machine shop has a journal that, say for instance, it had to be a machine on the crank on one of the main bearing journals, well then we'd have to get an undersized bearing for that. Typically the bearings are going to be stamped on the back with undersized, and it'll say 10 thousandths, 20 thousandths, 30 thousandths, 40 thousandths. And so some of them, very rarely that they're slightly scored up, 1 thousandths undersized will be the bearing on it, but it'll say that on there on the back of the bearing cap. And you want to make sure you check that when you get your crankshaft and your bearings. Typically when you get parts for the crank and the pistons, you want to get them from the machine shop. Okay, you don't want to go to O'Reilly's, and you don't go anywhere else, especially when you're getting the crank and the connecting rods machined at the machine shop. Oversized bearings is where we have an issue with the bore of the crankshaft. It has to, if it's slightly misaligned, we have issues with vibration. The bores are going to have to be a line bored from the machine shop area, and then we're going to have to put oversized bearings on it. So those will typically be stamped as well to make up for the increased clearance. So just kind of keep that in mind. Fast forwarding, guys, all the way up on chapter 21. Of course, we're looking at cylinder diameter on the very top on page 426. We'll be doing a demo on this right here to check for warpage on the deck surface area here. It's pretty much going to be the same way we did on the cylinder head on module 3. But this time we're doing the block. Okay, so we'll be measuring that. Anything above 3 thousandths to 5 thousandths block deck wear on it, and that block needs to be redone. Okay, or pretty much replaced, because we're going to have some excessive leakage with the head gasket. So cylinder wear taper, we're looking at on page 427. Study this really good, because this is kind of what we're looking at doing. I'll do a demo on this as well. Pretty much coming up pretty quick here, where we're showing the cylinder taper, and that's the difference between the top section and the bottom section of that cylinder. which will have problems with wear and tear of our piston rings, plus wear and tear and smoke. We'll see that out of the tailpipe with a bluish grayish smoke coming out, indicating that we're losing all out of the rear part of the tailpipe due to excessive cylinder wear. Out of round measurement, we'll take a difference of the front to rear, side to side. Typically we do that in 2 different areas, the top and the bottom of that cylinder. So we all understand that we have more wear towards the top than the bottom, so we're going to make that comparison and know that we had talked about this earlier, but our piston shape is not truly vertical, right? It's tapered, and it's meant to be that way because it's wider in the bottom and lighter at the top, or narrow at the top when it's cold, but when it heats, it expands. So we need to make sure that we check that out of round, cylinder out of round and taper to make sure that it falls within our specifications. So the other thing we look at, guys, and I kind of talked about this and I demoed this already, is cylinder honing and deglazing. That's just like after we've checked out what we did on the measurements on the outer round, the taper on the cylinder, we feel that it's okay to be cleaned up. We're going to do a deglazing, which I already demoed for you guys. And so kind of looking at doing a flex hone on that, or a brush on page 431 on figure 2115. I kind of demoed that for you guys the other day, or for this week rather. And so you kind of want to look at that. Okay. We will get a chance, like I said, to do the crankshaft in-play measurement, and we'll be using plastic gauge for that. So, and we'll check out the thrust bearing and see if it's got a good thrust bearing on the 2.2 engine that we have over here. So you guys be safe and look for the demos for that coming up this week on worksheet 15, last worksheet. Okay, guys, have a good day.